In this problem, we're asked to find the transfer function for the network below. Notice that it contains an op-amp. We'll utilize our problem-solving strategy for S-domain circuits, and also the one for op-amp circuits. And what we need to do is draw the S-domain circuit, and we need to insert our model for the op-amp used earlier in the text. And if we substitute that model in, there's our S-domain circuit. Here's a model for our op-amp. Remember, the currents into here are both 0, and remember that the voltage between these two terminals is 0. So there's our op-amp model. So now we need to just start analyzing this circuit. There's the S-domain circuit. So now, step 3 in our strategy is analysis. And if you remember back from our problem-solving strategy on op-amp circuits, it says use nodal analysis. And since the voltage across here is 0, this point is at the same voltage at the reference. So now, let's apply KCL at that node. So when we do, we'll have V sub S of S over R1. Okay, there's a current going that way. Then we have two currents coming back this way. We have V0 of S over 1 over SC1 plus V0 of S over R2 plus 1 over SC2 equal to 0. So there's our KCL equation. Now it's a matter of working through the algebra. So we can rewrite this equation as V sub S of S over R1 is minus V0 times SC1 plus 1 over R2 plus 1 over SC2. And continuing to work, we have SC1 plus SC2 over SC2 R2 plus 1. And continuing on, now we'll get everything in here over a common denominator. So we'll have in the denominator SC2 R2 plus 1. So we've got SC1 times SC2 R2 plus 1 plus SC2. And continuing, collecting up terms here, we have S squared R2 C1 C2 plus S times C1 plus C2 over S C2 R2 plus 1. So we're just continuing on with the algebra. Now we're trying to get V0 over Vs. Okay, so if we do that, if we solve this for V0 over Vs, we have minus S C2 R2 plus 1 over S R1 times S R2 C1 C2 plus C1 plus C2. And now if we factor out a C2 R2, the numerator becomes S plus 1 over R2 C2. And then we have an R1 R2 C1 C2 S times S plus C1 plus C2 over R2 C1 C2. And if we look, we can cancel out the C2 and the R2. So we are left with minus. We have S plus 1 over R2C2, and then we have R1C1S times S plus C1 plus C2 over R2C1C2. So now we've worked on it, so let's rearrange it one more time into this form. So now we'll have V0 of S over Vs of S. We'll have minus 1 over R1C1. We'll have S plus 1 over R2C2. We'll have S, and then times the quantity S plus C1 plus C2 over R2 C1 C2. So if we notice, looking at our transfer function, we have 1, 0, and notice it's at minus 1 over R2 C2. We have two poles, one of them at S equals 0, and the other one at S equal minus C1 plus C2 over R2 C1 C2.